So I'm Nina Tannen. I'm from Epibone, which is one of the Breakout Labs companies, and quite simply, we grow bones from stem cells. I think I've got 5 minutes, right? So deep breath. So a lot of things that a lot of people don't realize that after blood transfusions, bone is the most commonly transplanted human tissue. Did you know that? 2 million procedures worldwide, 5 billion a year, and you know the only way to get human bone, quite simply, is to cut it out of a human, right? And if you think about someone like Roger Ebert, who lost his jaw due to salivary cancer, and they reconstructed his jaw from a piece of his hip and a piece of his shoulder, and it didn't take. And then he lost his jaw again, right? And then ended up spiraling in terms of, you know, he fell down. His posture was impaired and things like that. This is just not the way we should be doing things. And if you think about children, there's just not enough bone to go around, children with congenital defects and the like. And so, you know, just after this last panel, I was also thinking, yes, you know, it's also, you know, a lot of times we talk about people living longer and longer and needing musculoskeletal solutions, right? We had our panelist who's due for a hip replacement in a week. So we have this whole baby boomer population thing happening where people are needing more and more orthopedic solutions. But on the other hand, people are getting injured earlier and earlier in life. 400% increase in ACL tears for high school age kids in the past 10 years. So, you know, it's not just that we need solutions that you know, for older population, but we need solutions for the younger population to last a lifetime, right? And so what we do is we say, you know, if the only way until now is to get human bone is to cut it out of a human, why not use the stem cells that grow our bones every day in our bodies and use those to engineer bones in the lab, right? So that's what we do, essentially. So we take two things from the patient. We take a CT scan, just imaging, so that we can get the three-dimensional data to be able to engineer an anatomically precise piece of bone. And we also take a fat sample from the patients, from abdominal fat, because we take the stem cells out of those. We put those together. So that's the part that the panelists didn't talk about. They said cells and scaffolds. What about the bioreactors, people? So that's what we do. We take the cells and we engineer the scaffold to be in the correct shape, and we combine them in our bioreactor. And in 3 weeks, we can engineer a piece of anatomically precise, living human bone that's ready for implantation and does not get rejected because it's made from your own cells. Thank you for talking about autologous cell therapies in the last session. This is how it works. The CT scan, these are the cells growing, and we machine the scaffold into the correct shape, infuse the scaffold with the cells, and that's our bioreactors. Cells are getting fed, in 3 weeks we've got the piece of bone. So if you've got a piece of living human bone, it's you know, as opposed to synthetic implants or cadaver parts, or even cutting a piece of bone out of one part of your body and putting it in another. These are the main competitive products to what our product will someday be. We think that Epibone is better for 3 reasons. Firstly, because there's a perfect fit. It's in the correct size and shape. Secondly, because it's from your own cells. There's no chance of rejection. And thirdly, because it's alive, it can continue to remodel and grow along with you. So here's some science. We're at the preclinical stage. We've tested our bones in pigs up until now, and you can see after 3 months and 6 months that the Epibone graft, it connects and really integrates with the host tissue after 6 months. And we talked about vascularization in the last session. One thing that's interesting is that even though we're not vascularizing the tissues while we grow them in the lab, after implantation, we saw these beautiful lumens, okay? And to Ryan's point in the last session, we stained those lumens to see, are they in fact lined by endothelial cells? Yes, that means they're blood vessels. But are they filled with blood? Yes. Right, so we saw this beautiful example that if we grow the bones in the lab, because of the stem cells that are used to engineer these bones, they actually get new blood vessels infiltrating them post-implantation, which was super exciting. I'm out of time, so I'll just tell you that we're a Breakout Labs company. They were our first investors, exciting. But we've just closed last fall on $4.2 million. We did a friends and family round in which the New York City Investment Fund actually participated. We have a new lab in Harlem. We're super excited. And we'd love to continue the conversation with how, you know, anyone here in the audience, with how we may work together. So thank you so much for your time.